Now let's see the eclipse movement with 3D model. You can use solar system scope. It's supposed to be correct according to heliocentric model. The time, speeds, directions, and eclipse duration are to scale. Only the sizes are not to scale. They make them bigger to make it easier for you to see the movements. Set your time to August 21st, 2017 at 3:55 p.m. UTC. We'll run it for 5 hours, scaled to about 5 seconds. It's gonna be quick, but we can replay it. The time will be 3:55 p.m. to 8:55 p.m. Please focus on the Earth's rotation speed and direction, also the Moon's orbital speed and direction. See which one is faster. Ready? Go! You see that the Earth's rotation is faster. Let's zoom it. The Moon is almost like not moving. That means they are using angular speed. The Earth rotating at 15 degrees per hour. The Moon's traveling at 0.51 degrees per hour. With this angular speed, to which direction the shadow goes? Because the Earth is spinning faster to the east, the Moon's shadow goes the opposite direction, from east to west. Exactly like Najwa has shown you, only this 3D animation is using true scale of speeds according to heliocentrism. But don't trust CGI cartoons. Let's make a real-life model now. This time, I collaborate with Pupum. He is a technical engineer and a very diligent researcher. He made our previous AutoCAD scale model into real-life model. This is the Earth and the Moon's model to scale. This is the Moon's traveling distance in 5 hours. And this is the Earth's rotation in 5 hours too. This is the Earth-Moon distance. You remember those angular lines. The Moon travels 18,415 kilometers, but is only 2.55 degrees from the Earth's axis. That's the true sizes, distances, and speeds according to heliocentric model. Assisted by Dama as cameraman, we put 3 cameras on the model. First one is above the Earth to see the Earth's rotation angles. Second camera is above the Moon to see the Moon's traveling distance and angles. Third one is behind the Moon to see where the shadow falls in 5 hours time scale. Remember, we're not looking for the eclipse shadow size. The source of light with the scale should be 475 meters or almost half kilometers away, and the lamp diameter should be 4.36 meters. It's irrelevant for this purpose because we're just looking at the shadow's direction, not the shadow size. We start from the 0 point where the eclipse starts. You see the Earth is at 0 degree position and the Moon is also at 0 degree position. The shadow is slightly to the west of the Earth because the eclipse started at 15:55 UTC or 10:55 local time in the morning. If you stand on that shadow point on Earth, you would see the Moon is slightly to the east where the Moon rises as appears on Earth. Now the Earth rotates for 15 degrees. The Moon is moving 3,683 kilometers, but only 0.51 degree from the Earth's axis. See where the shadow falls. Oops, it's not angular speed, but linear speed. This is a disaster for the globe model. Yes, it means the shadow moves from west to east, but it means the Moon is setting to the east, and within 3 hours, the shadow will go outside the Earth. Second hour. Third hour. You see the shadow already falls outside the Earth. Fourth hour. It's more than the Earth diameter. This is the fifth hour. The shadow goes half Earth outside the Earth. How can heliocentrism predict eclipses if the maths don't even add up for one eclipse? No wonder NASA still uses ancient Babylonian solar cycle.